Okay, I am Farzad Nikfam, and my PhD is about machine learning and artificial intelligence (AI). In particular mode on the security and the privacy problems. We can start talking about AI. I know that some of you knows what it is, but in general we can say that is a powerful technology. We can do a lot of things with AI. We use AI in our daily lives for many years, for example in spam filters or weather forecasting. And nowadays we are implementing AI also in autonomous driving or virtual assistants. It can be also used for other things like as facial recognition to unlock devices or something like this. I hear a lot of times that people that ask me AI is powerful, but I am afraid of AI because in the future maybe it will steal my job. Okay. It's correct, more or less. Some jobs will disappear, but other jobs will appear. But the real problem of AI is not this, but the risk that we have with AI. Like as other field of computer science, we have problem in security and privacy. We can see some problems. We all know what is ChatGPT. In the last year, ChatGPT became so famous. We can use ChatGPT to ask useful information. For example, for us that we are doing a PhD, we can ask to rephrase a concept because we have maybe to write a paper. We don't know how to rephrase a concept in English. If we ask to ChatGPT, it will do for us. But we also can ask to ChatGPT if he can say how to build a bomb. Okay, this is not so a good idea. And for this problem there is a limitation. You cannot ask this to ChatGPT. ChatGPT is in a group of AI that are called GAN, Generative Adversarial Networks, and you can generate with this type of AI a lot of different things. You can generate text, you can generate image or videos or songs. And there is problem in all of this field because you can create deepfake that can be funny, like in this case that you have the Mona Lisa with his face that is moving, or you have normal people that can become Tom Cruise. But if you use in a not usual manner, you can also ask to a generative AI to create a nude content of an actor, or you can ask to create a video of a politician that maybe say something that is not so good for his country. So there is a problem of security. Another problem may be with health data. We can use health data to do a lot of things because with AI we can predict cancers, disease. But this data are so important and we need to maintain the privacy. For example, we are here in Italy, but in other states, in other countries, like the States, in the USA, you need a health insurance. But if a health insurance company knows that you have a more probability to have a cancer in the future, maybe it will not insure you, or an employer maybe will fire you or will not hire you. And maybe can be also other risks that are bigger. If you have a specific DNA or a specific blood group, you may be eligible for illegal organ traffic. And this is a problem of privacy and security. Another problem can be in data of the bank. There are a lot of numbers in the data bank that can be used to predict the stock market or to check the transaction accounts, but with poison injection you can change this data, and this is a big problem. And there are also problems with biometric devices. When you unlock your smartphone with your face, if the smartphone will unlock also with your photo, it's a problem. Or if with your twin, if you have a twin. Okay, now I will show you two problems that I have touched in my PhD. One about privacy and one about security, and how our team solved this problem. In this case, we have an example of an adversarial attack. That is we have talked about adversarial attack at the beginning in the GAN, generative adversarial network. But in this case, adversarial attack is not a good thing, because you cannot generate nothing, but is a problem, because with a model that can perform with an accuracy of 90% maybe, after an adversarial attack maybe the model can reach only 0 or 5%. How it works? You have an image in this case. On your left there is a macaw, an image of a macaw. You add some noises. I have amplified the noises to show, but the noises more or less. At the end, on the right, there is a macaw for us, for a human being. But for the model, this is not a macaw, this is a bookcase with an accuracy of 89%, so very high. This is this is not a problem with a macaw, but if this model is inside an autonomous driving, it can be a very big problem. How we can create models that are strong towards adversarial attack? The simplest way is to use model trained on adversarial images. When we train model on adversarial images, it took a lot of times. So this is a problem. What we have done was to try to speeding up this type of model with some changing to the training. We try to change the shape of the learning rate. The learning rate is one of the most important hyperparameters for training the models. Normally the learning rate is constant, but in literature also exists other type of shapes, like the one cycle. We created the Axel AT, that is a type of shape of learning rate that it's dynamic. What I mean? It changes on the with respect to the gradient of the accuracy. When the accuracy reaches a plateau, the learning rate decreases. How we can see the results are more or less clear. Where the black line are the results that we can obtain with a model strong towards adversarial attack, but trained with a constant learning rate. The blue line is the Axel AT, and the orange yellow line is the one cycle. With dynamic learning rate, we can obtain an accuracy of 40 or 50% in more or less 20 epochs. This was a problem of security, and now we will show you a problem of privacy. To encrypt your data for privacy, you can use homomorphic encryption. In this case, we use full homomorphic encryption. That is, you have a data. You encrypt your data with public key, then you send the data to the server. In the server there is the model. The model can do the model can do whatever he wants on the data, because full homomorphic encryption works with addition and multiplication. Then after this, the data are sent back to the client with a public key, with a private key. Sorry. They are decrypted, and at the end you have a result that is more or less the same as the model trained without the homomorphic encryption. Also in this case, with homomorphic encryption, you have some problems of time, because you need time to do the encryption. We try to obtain a lower encryption, because when you encrypt some data, there is a trade-off. If you encrypt too much, the data is not readable. It is okay, but it is not usable, because you cannot come back to the original data. If you, on the other hand, if you do a too low encryption, you can use your data, but it is readable, so it is useless to do the encryption. But in this case, we try to do a comparison between DNN and SNN, DNN and deep neural networks, the typical networks for machine learning. This SNN are the spiking neural networks that are more similar to the human brain. A spiking neuron works like a human neuron, and there is a delay when it acts. We try to do this comparison, and we obtained that for lower value of t, that is a parameter of the encryption, we can obtain higher accuracy with the spiking neural networks. With lower parameter of t means that we can do the same thing, so we have encrypted data but in lower time. And we have showed that it's better to use spiking neural network instead of the deep neural networks in some cases. And with this, thank you, that's all, and if you have questions, thank you.
I have a curiosity, actually. I'm not expert in neural networks, so probably would be a stupid question.
No.
And in the last slide, you showed the difference between DNN and SNN.
Okay.
So you said that there is an advantage in using SNN for lower value of t in the encryption.
Yeah.
But which is the actual advantage in using it? Which is the difference between the two?
Because with a lower value of t, you need less time to do the encryption. So you can.
Matter of time.
Yeah, matter of time. Yeah.
Okay. Thank you.
What was?